Hello class, it's Mr. Kaplan here again, and I'm here now presenting the third lesson for chapter 6, which is going to introduce you to a new type of graphing called graphing a line using intercepts, specifically the x and the y intercepts here. So that's what we're going to look at in today's lesson. Now, before we begin, just going to go back to our magic board over here. So as you can see here, we have the two equations of lines that we've seen up until now over here. So starting from the left side, where we left off from the last lesson, okay, the equation of a line on the left side, this was what was called standard form. Now, anytime we are drawing lines, okay, we must change it into another form because this form for the standard form, for the most part, doesn't really tell us too much information. So what we had to do, and we learned it in the last chapters, we had to change the standard form and convert it to slope and y-intercept form. Okay, and just a couple of lessons ago, we learned how we could graph that using the slope and the y-intercept, because remember what we had to do there was to plot the y-intercept first, then use the rise and the run from the slope to plot the second point. All right, so in order for you to draw graphs using any type of equation, you must change it into either slope and y-intercept form or the form that we are going to look at today. So today's form over here doesn't really have a name. I just gave it a name because of the technique used behind it. And basically, what we want to do here is that anytime you see an equation that looks like this, where you have the x and the y on the same side, okay, and a number on the right side, okay, the way that that you're going to graph an equation that looks like this is what we're going to look at in today's lesson. And this is, I just call it the intercept form, simply because we are going to use intercepts in order to draw a straight line. Now, in a very similar fashion to using the slope and the y-intercept to plot a line or to draw a line, you only need 2 points in order for you to construct a line using the intercept form as well. So that's what we're going to look at in today's lesson. So let's get right to it here. And there's Borat, yes. So let's take a look at how to graph a line using intercepts here. Okay, so when we're dealing with intercepts, okay, there are only two intercepts that we are going to look at in this course, and they are specifically the x-intercept and the y-intercept. Now, the y-intercept is going to be very, very familiar to us in this chapter because it's what we look for to come up with the value for b in given the equation y equals mx plus b. Now, what we want to know about today's lesson again is that we're going to look at the x-intercept and how we're going to use the x-intercept and the y-intercept to construct a line. So remember that the x-intercept is where a line touches the x-axis, which I've designated in the red there. Now, at that point there, okay, what the x value is wherever it touches the x-axis. However, the important part of that point there is the value for y, because for the x-intercept, the y is always 0. That's why I've designated that in the red there. So when you're looking at the coordinates that make the ordered pair of an x-intercept, the x is always where it touches the x-axis. However, the y must always be 0. Now, the y-intercept, as we've said several times already, is where the line touches the y-axis. Now, what's important about that, okay, this is the point in the green here, or greenish-bluish color here, okay? The coordinates of this particular line, there's something that's also very similar to the x-intercept, okay? So when you're looking at the coordinates for the y-intercept, it's the x that is always 0. Now, you're probably wondering, what in the world is the y going to be? Well, the y is simply the coordinate that touches the y-axis. Okay, so it's basically the y-intercept if you want to look at it that way. But notice the numbers I've outlined in red there. Okay, those will always remain the same for those two specific intercepts. Now, when we are solving for intercepts given the equation in intercept form here, what we want to do here is to let the other letter be 0 and then solve for the remaining letter. Okay, so if there's one instruction that you need to put in your head there, it's this one over here. Okay, so that's why the finger's pointing at it, so it sticks right up there. All right, so again, you can see here the key idea for all the questions involving the solving of intercepts is letting the opposite letter equal 0 and then solving for the remaining letter. All right, let's get right to it. Okay, start off with the first one here. So we have an equation over here of 2x plus 3y is equal to 12. Now what we want to do here is to solve for the intercept first and then graph it and then construct the line. Okay, so when we are solving for the x-intercept, okay, that means we want to have the the x coordinate of the ordered pair that's going to be on the x-axis. So what we have to do to solve for the x-intercept is we have to let y equal to 0. Okay, now when we do that, all we're going to do here is to take the 0 and then substitute it in for the y like this. All right. Now remember that when you multiply a number to 0, it's always going to give us 0. So another way we can deal with it is just simply just to cancel that out. And you can see what's remaining here is going to be 2x is equal to 12. Now you can see in this step over here, our final step, we just need to solve for the x simply by dividing both sides here by the coefficient. And this will give us a value here of x is equal to 6. Okay. Now remember that this is the x-intercept. So this point over here is going to be the point that's going to be directly on the x-axis, which I have in the red there. All right. Now remember from the previous slide, to solve for an intercept, you have to let the opposite letter be 0. So to solve for the y-intercept, we have to let the x equal to be 0. Now you're going to proceed for this one. Again, the steps are exactly the same. All I'm going to do for this one here is I'm going to take the 0, but then this time replace it in for the x. Okay, and then 2 times 0, that's going to give me 0. So we only have the 3y and the 12 remaining. Okay, and as you can see that when you get to this step, our final step over here is we need to divide both sides with a coefficient, which in this case here is 3. And now we have our y-intercept for this particular question to be 4. All right, and that wraps up that example. So connect these 2 points to a straight line. Okay, and don't forget to extend and getting into the habit of extending there. All right. Okay, so again, what we had to do here to solve for an intercept, you have to let the other letter be 0 and then solve for the remaining letter in the equation. Okay, let's take a look at another one. Now, just pay attention to this one over here because notice that I have both the x and the y on one side and the number by itself on the other. Okay, this next question, even though it looks different, okay, the approach is actually exactly the same. So going back to solving for the x-intercept, again, stick to the basics. We're going to let y equal 0. Okay, and from here, we're going to do it in this next step here. And you're going to see in this case over here, when the y gets replaced by the 0, okay, the -2 times 0 gives us 0. And you notice what's remaining here is the 6x and the 24. Now, the only difference between this question and the last one is this next step here. Because remember what we want to do here is to solve for this x. So we're going to leave the x exactly where it is, and we're going to take the 24, okay, move to the other side, and then that becomes negative. Okay. And last but not least, divide both sides here by 6. And we have our first intercept to be x is equal to -4. So for this one here on the left side, okay, we're going to plot a point right there. Okay. All right, now that you've seen a couple of examples, take a moment to pause the video, and I want you now to solve for the y-intercept, exactly the same way that we did in the previous slide. All right, so to solve for the y-intercept, okay, all you have to do here in this case again is let the opposite letter be 0. So the opposite letter for this particular for the y-intercept is going to be the x. So we're going to let the x equal 0 and then substitute it in for the x. Now for this one again, don't forget when you multiply a number to 0, it's always going to cancel out and become 0. And we have -2y and 24 equals 0 remaining. Okay, don't forget this is a -2 over here. Okay, so since this sign is attached to the -2, we have to keep that in mind for the final step for this one. All right, so for the next step, we're going to take the 24. Okay, subtract it to the other side over here, like so. And last but not least here, we're now going to divide both sides here by -2. Okay, and what happens over here? Well, -24 divided by -2, that's going to give us +12 right there. Okay, and last but not least, connect the 2 points there with a straight line. All right, so you've now seen 2 basic examples here. Now, what we want to do in the next example is we want to revisit this, okay, in a something similar to it, okay, and go a step further and actually calculate the slope from there. All right, so let's take a look at what to do for that one. Okay, now for this one over here, Okay, the intercepts, we actually don't need to solve for them, okay, because they're going to be given to us already. So it says here, determine the slope of a line whose x-intercept is -4 and y-intercept is -8. Okay, notice we have a graph there to help us out with this scenario. Now we are going to look at this exact same question two different ways because I want you to also be accustomed to seeing this type of question in the event that you do not have a graph. Okay, all right, so we're going to start off the first examples by doing it by graphing. So let's plot the points first. We have an x-intercept of -4. So from the center, remember the x-intercept is the point on the x-axis. So that's going to be this point over here. All right, and the y-intercept is -8. So from 0, 0, we're going to go down 8. All right, and let's connect. Now, before we actually look at this calculation of the slope of the line here, which we're going to, by the way, since it's a graph, we are going to use rise over run. Okay, let's talk about this line first. Okay, what we know so far is the fact that it is a line that is going down to the right. Okay, and again, just as a reminder, you should go through these steps so you should know what the direction of the line will be when you're coming up with your final answer. So since this line is going down the right, our slope has to be negative. Okay, so just make sure that when you're doing the calculations that you put the negative sign as we go along in the solution here. Okay. All right, so since we're using rise over run, okay, we're going to construct a right triangle underneath it like so, and just count the number of boxes because they're all going up by 1. All right, so if you're looking at this dot over here, we're just going to count the number of boxes. So we have 1, 2, 3, 4, 5, 6, 7, 8. So we have a rise of 8. And so take a look at a run starting on the bottom right-hand corner. We have 1, 2, 3, and 4. All right. Okay, so if you take a look at the rise over run, don't forget it is a negative slope. So that's going to give me -8/4. And if you plug that into your calculator, that gives us a slope here of -2. All right. So just a quick recap. Again, we drew the points in. We used a right triangle to calculate the rise over run using the formula rise over run. And you notice it gave us an answer here of -2. Now, we're going to look at this question again, but this time we're going to pretend that we don't have a graph there, okay? So we're going to use another method, okay? And that other method is using the y2 minus y1 over x2 minus x1 formula. All right, now when you're setting this up, okay, and you will be expected to solve this type of question without a graph. What you have to understand is that every intercept is an ordered pair. So before you actually solve for the slope, what you should do is to express each intercept as an ordered pair, all right? Now, starting off with the x-intercept of -4, remember in the very first slide when you have an x-intercept, okay, the y is always 0. So to express the x-intercept as an ordered pair or a coordinate, what you would have here will be -4 and 0, all right? Now, for the y-intercept over here, that's this point over here, okay, remember that for the y-intercept, it's the x that is always 0. So for the y-intercept, in the first spot, which represents the x, that would be 0, okay? And the -8 would go in for the y, okay? So just to make a note for this one, I'm gonna put these in the red, okay? Notice that for the x-intercept, okay, the x is, the y is always 0. And for the y-intercept over here, okay, the x is always 0, okay? So just keep that in mind. That's always going to be the case. And again, this is important, especially when you don't have a graph. And then the graph is only here for demonstration purposes, all right? Now, next thing we're going to do, we're going to calculate the slope of these 2 points using the fancy formula. And just like we did with the previous examples using this formula here, okay, you always label the first point as x1 and y1, okay? So nothing has changed. The only difference is that we're not using a graph to label our points. That's basically it. All right, and then for the second point, this will be x2 and y2. Now, another reason why I'm also doing this specific example, again, is that when you're doing this next step, you do have to remember the rules of integers. Okay, you're going to see that when we put in the values in, starting off with y2 minus y1, we have -8 minus 0 on top. However, it's the bottom part that you need to pay close attention to. Notice that for x2 minus x1, okay, x2 is 0 minus. Now notice the x1 here is a -4, okay? So this negative is attached to 4, okay? It's not the same thing as the minus sign. So that's why on the bottom part over here, and remember that when you have 2 negatives, okay, what you're really doing there is added, okay? Because that's just from the rules of integers that we looked at in the very beginning of this course, all right? That's the only thing you just need to be careful with for this question. So what we have here will be negative 8 over 4, and just like the previous question, that will reduce to 2. Okay, so again, for this one here, we looked at this particular example in two different ways, just to show you again another method. You can calculate the slope, this time using the a special formula over here. I also wanted you to see how to set up intercepts as coordinates as an ordered pair when you do use this particular formula. All right, and that's it for this lesson. So that wraps up the third lesson for chapter 6, and I'll see you at the next lesson.